Hello, Year 9. I thought I'd give you a little opportunity to talk through the answers to lesson 17 about forming ions. This is part of this unit of chemistry that we're doing at the moment. So I've written down the elements that we're going to be looking at, and the main thing to say is that we will follow on from our previous lesson about filling them. So calcium is element number 20, and so it's got 20 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, the thing about atoms is that the electrons form in shells, but an atom who hasn't got a full outer shell is an unstable one. And so what it will try and do is it will try in one way or another make sure that its final shell is a full one, which means generally that metals, calcium's a metal, will do that by losing electrons. And you can see these two electrons here are sitting in the outer shell. And so the calcium's quite happy to sort of donate those to someone else to get rid of it. And you generally find that that's the case with most metals. Most metals have their chemistry by losing electrons, and it's the losing of electrons and the gaining electrons that is chemistry. Without it, we wouldn't have any reactions, we wouldn't have any combustion, we wouldn't have any photosynthesis, we wouldn't have any life. Chemistry would be very easy, electrons sitting in shells, but there would be no chemical reactions. So it's going to lose 2 electrons, and so its original configuration is 2, 8, 8, and 2. That adds up to 20. It's going to find itself now going to lose those last 2. Okay, so it's going to go to that. I'm going to draw that out now. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14, 15, 16, 17, 18. That's the electron configuration for the noble gas argon. And so argon has got a full outer shell. That's why argon doesn't tend to react. Well, calcium has to form itself an ion to become that. An ion is a element that has not got the same number of protons and electrons. In this case, what we do to show that is we draw a bracket. If we put a bracket around it, we're telling the reader that this species here, this thing here, doesn't have the same number of protons and electrons. In fact, actually what it does is it has 2 more protons than it has electrons because it's lost 2 electrons, and so we give it a little symbol there to show that it's actually lost 2 electrons. Okay, let's go on to the next one. Right, aluminium is element number 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This has got now 3 electrons in the outer shell, all of which, okay, are making the atom unstable, and so it will rather lose those electrons to something else, give them away to something else, than keep in that condition. And so what it does then is it loses those electrons. So its original electron configuration is that, okay. The 3 there means that aluminium's in group 3, and it's going to go to this electron configuration. 2, 8. This is the electron configuration for neon, a noble gas. Okay, so it's now got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. We have to put the bracket around the outside because we now have an ion. We don't have an atom anymore. Atom is in the periodic table. It's lost 3 electrons, so it's 3 plus. It's got 3 more protons, it's got electrons. So that's the aluminium, that's the aluminium ion. Let's do fluorine. Fluorine has got an electron configuration. 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons, a 2 and a 7. Fluorine is in group 7. It's got 7 electrons on the outside. Now fluorine's not going to lose 7 electrons. That's a big deal to lose 7 electrons, but it's more than happy gain an electron, and so it will gain 1 to become that configuration. That's now the configuration of neon. It gains that electron from a passing atom, maybe even an aluminium or a calcium has given it one of its electrons, but it's now not an atom anymore, it's an ion, because it's got more electrons than it's got protons. And if it's got more electrons than it's got protons, and so what I'm going to draw is draw this extra electron it's gained as a different one, then it's now minus. It's got -1. Don't tend to write the 1, but it's just a -1. Okay, on to sulfur. Right, sulfur, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2, 8, and 6. Sulfur is in group 6. Now again, that's not a full outer shell, okay? And so it's not going to lose 6 electrons. It's going to be a big deal if it did. So what it's going to do is going to gain 2 electrons. So it's going to get this configuration, 2, 8, 8, which is the same as argon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. I'll draw these 2 as red ones because we've gained those from somewhere else. Okay. And that's an ion because it's got more electrons than it's got protons. In fact, actually, it's got 2 more electrons than it's got protons, and so its charge is -2. Moving on, nitrogen, is got 7 electrons, so it's got a configuration of 2 and 5. You'll find nitrogen in group 5. It can't lose 5 electrons, but it can gain 3 to become this: 1, 2, 3, 4, 5, 6, 7, and then 3 electrons that it's gained from a passing metal, probably, to become that, 2 and 8, which is the configuration for neon. And they are. It's got a brackets around it because it's now got a charge, and you can guess the charge. It's now got 3 extra electrons, so that makes it a 3-. Okay, final last one, lithium, 1, 2, 3. It's in group 1 because there's 1 electron on the outer orbital. It's not going to gain 7 electrons, but it quite happily lose 1 electron to become, so it goes from 2, 1 to a 2. Okay, that's the electron configuration for helium. Draw my brackets around the outside because the protons and electrons aren't even anymore, aren't the same number anymore, and so it's now it's lost electrons, so it's a +1. Okay, so hopefully that'll help you, and that's our ionic configurations. Okay, so these are our atoms, these are the ions they form. Yeah, thank you very much.